In this video, we will solve a numerical problem on exchange economy with two-person, two good model, and each person's utility function is being given us and the initial endowment of the two persons. Okay, so I have just cut short this problem. It was very lengthy, so I just try to summarize it here. We are being given the information about two-person, two good exchange economy model. Utility of person A is being given by this xa1 times xa2. So these are not the exponents here. Remember, 1 and 2 denote the good 1 and good 2, and xa denote the agent A. Okay. Similarly, for agent B, the utility function is being given us as min function. So minimum of xb1, xb2. Okay, xb1 is units of good 1 that person B demands, and units of good 2 person B is demanding. Okay, also we are being given the initial endowment. That means good one that person A has initially is 0, and units of good 2 person A has initially is 10. Similarly, endowment for agent B is he has 20 units of good 1 and 5 units of good 2. We have to find out the market equilibrium relative price. Okay, also calculate the gross and net output for each good, and also we will try to show it on Edgeworth box if time allows us. Okay, so how do we solve this kind of question? If this denotes the endowment, this is the utility function. So this is a Cobb Douglas utility function. Okay, and this is our Leontief utility function or min function. First step in solving this question is we will try to find out, you know, the income of person A. Okay, so endowment is being denoted by this. So we can also write in place of endowment W. A denotes the endowment of person A is equal to WA1. So units of good 1 person A has initially, and WA2 shows us units of good 1 person 2 has person A has initially, good 2 sorry rather. Similarly, let's denote WB as the initial endowment of person B. So we have WB1 units of good 1 person B has initially, which is 20, and WB2 shows the units of good 2 person B has initially. Okay, this is utility function, this is the endowment vector here. Okay, first step is we will calculate the total income of person A. So let us denote it by M subscript A shows us the total income of the person A. And what is the total income? We assume that there is no outside income. Whatever person has is their endowments. Endowment is their income. Okay, so what will be the income of person A? Simply price of good one times WA1. That means price of good one times units of good one person A has initially, plus P2 price of good 2 times units of good 2 person A has initially. This is the income of person A. Symmetrically, what will be the demand, income of person B? Let me write it here. Income of person B will be equal to price of good one times units of good one person B has initially, plus price of good 2 times units of good 2 person B has initially. Okay, first step is to find the income of person A and person B. Now we will also try to find out the total supply of good one. Okay, so let me write it here. Supply of good one is equal to, what is the total supply of good one? Simple thing, total supply of good one will be equal to WA1 units of good one person A is holding initially, plus WB B1, units of good 1% B is initially holding. Okay, and what is it equal to? WA1 is 0 plus WB1 is 20. So total supply of good 1 is 20. Okay, now we need to find out demand, uh, demand for good, demand function for person A. Okay, so let me write it here. Then second step will be to find out the demand. Okay, this is the utility function, this is the budget constraint of person A. What is then demand? Since we have the Cobb Douglas, we can easily find out the demand functions. That is, demand of good 1 by person A will be equal to, okay, I should have used the star here also to differentiate it with this, so it will get messy here. So this is the demand function of good 1 by person A will be equal to total income of person A upon 2P1, that means price of good 1. How did I get this? Simple thing, I will add the video on how to find the demand functions from Cobb Douglas utility function and minimum, what we call Leontief utility function, in the end of this video, where I will explain how did I get this very function. If I try to you know derive it here, it will take a lot of time and you will not get the idea. Okay, so remember xa1 is equal to this, and I have derived it in the last session of this video. I will add up that very video in this video also. Okay, so this is demand function for good 1 by person A. Similarly, demand of good 2 by person A will be equal to total income of person A divided by 2P2. Okay, what about person B? Utility function is minimum, what we call Leontief function. And what will be the demand in the case of person B? So for person B, demand is equal to x, x1 B will be equal to total income of person B divided by P1 plus P2. Don't get confused, I have explained this, rather I will explain this in the last session of this video. Okay, and what is the demand for good 2 by person B? So let me write here, xb2 will be equal to total income of person B divided by P1 plus P2. Okay, so this is the demand function of your Leontief utility function. These are the demand functions of Cobb Douglas type utility function. Okay, now next step is to find out the market for good 1. Okay, so market for good 1. Okay, by market of good 1 we want to find out demand should be equal to supply. Okay, now what is the total demand of good 1? So total demand of good 1 is x1a, what person A is demanding of good 1, and xb1, what person B is demanding of good 1. So that means xa1 plus xb1. So total demand of good 1 by person A and B should be equal to total supply. And what is supply is nothing but the initial endowments of good 1 holding, which is being held by person A, plus WB1, units of good 1 person B is holding initially. So demand for good 1 should be equal to supply of good 1. And demand of good 1 we have calculated it here. Okay, so demand of good 1 is being given us as, in place of this I can write this MA upon this, and MA is equal to this, or let me write it here. So I can write it, so XA is equal to this stuff. Let me write it here, I just want to save the space. So XA is this, and in place of MA we have this. Okay, I'm just trying to subsume two steps in one. So in place of ma, so xa1 is this, so ma is p1 wa1, so I will write p1 wa1 plus p2 wa2. Okay, this is ma divided by 2p1 plus what is x1b. X1b is this mb. Okay, so this is x1b. I just want to substitute this here, and mb is equal to this. I'm just trying to save some spaces here. Okay, so let me write it here. In place of mb, I have p1 wb1 plus p2 wb2 upon p1 plus p2 should be equal to supply, and supply is wa1. What is wa1? This is 0 plus what is wa2, sorry, wb1 is 20, so 0 plus 20, which is wa1 plus wb1, which we calculated earlier. This stuff is equal to 20. Okay, now what we need to do here, we will try to assume. Okay, so let me write it here. Let us write, let price of good 1 is equal to 1. Oh, so, okay, so we are setting p1 as numeracy here. Okay, so we cannot take it always, but in this question, when one function is well behaved and another is not, in that case we can take a price of any of the good as equal to 1. Okay, we assume price of good 1 is equal to 1, but we cannot take it in any kind of exchange economy model. Okay, so I will not go into that very depth, in which case we do take numeracy as the price. Okay, so for the sake of generality or simplicity, let us take price of good 1 is equal to 1. Okay, if price of good 1 is equal to 1, let us solve this very function. So p1 into wa1. Okay, p1 is 1, wa1 wa1 is 0, so we will get here 0 plus p2 wa2. Wa2 is 10, so I can write here 10 p2, okay, upon twice p1, so 2 into 1 plus p1 wb1. P1 is 1. What is wb1? Wb1 is 20, so I can write it here 20 plus p2 wb2. So p2, what is wb2? Wb2 is 5, so I can write here 5 p2 divided by p1 plus p2. P1 we have assumed equal to 1 plus p2, okay, should be equal to 20. Okay, so this denotes the demand for good 1 by person A and B should be equal to supply of good 1 holding supply of good 1. Okay, now let's try to solve this stuff. Okay, so let us remove this for the sake of simplicity. Let us do some calculation. So multiplying this, we have 10 p2, okay, 10 p2 plus 10 p2 square. Okay, just multiplying this plus, so it is only 2 here, so we get here 2 20s are 40 plus 2 5s are 10 p2 divided by 2, multiplying this 2 with each of the term here, so we will get 2 p2 should be equal to 20, or 10 p2 plus 10 p2 square plus 40 plus 10 p2 is equal to, taking this here, so this becomes 2 into 20 is 40 plus 40 p2. Okay, so this is 10 p2, 10 p2 is 20 p2, so we get 20 p2. This 40 and 40 will get obviously cancelled. We have here 10 p2, 10 p2, so we have 10 p2 square plus adding these two becomes 20 p2 should be equal to, we have 40 p2 here, that means 10 p2 square is equal to, transposing this it will get subtracted, so we will get 20 p2. Okay, So we have P2 here, P2 here. We can cancel one P2 easily, or I can write it something in this form. 10 rather P2 square is equal to, am I doing the calculation right or not? Let me see. Yes, I am doing it perfectly right. So 20 upon 10 into P2. Okay, so we can cancel one P2. That means we get P2 is equal to 2. Okay, so price of good 2, we got 2. Let me rub this sheet here, which implies when I solved this stuff, I got P2 is equal to P2 is equal to 2. Okay, so we just want to find out the equilibrium price ratio. Now let me rub this stuff. Price of good 1 is 1, price of good 2 is 2. That means equilibrium price ratio is equal to P1 upon P2, which we got P1 we assumed 1, P2 we got is 2. So 1 upon 2 will be the price ratio, which is the slope of the budget line. Okay, having done this, what are the gross demands of good 1? So we can also calculate this gross demand. So P1 is equal to 2. In this case, then what is the total income? Now total income of person 1 will be equal to, price of good 1 is 1, units of good 1 person is holding is 0, so we have 1 into 0 is 0, but price 2 P2 we got as 2, so we have 2 into 20. That means, or let me write it here, P1 was 1 into units of good 1 is 0, plus P2 is 2 into units of good 2 person A is holding is 20. So we got it as 20. This is the income for person A. And what about person B? Person B, P1 into WB1. P1 we assumed 1, WB1 is 20, so we get here 1 into 20 plus P2 we got 2 and WB2 is 5, so 2 5s are, okay, so 2 5s are 10, so 2 into 5 when solving this becomes 20 plus 10, which is 30. Okay, now what is the gross demand of good 1 by person A? Just find out this very stuff in this equation. So XA1 is MA upon 2P1. MA we got as 20 twice P1, so P1 is 1, so we get 20 upon 2, which comes out to be 10. Okay, and what about X to B? That means gross demand of good 2 by person A, will be equal to M upon 2P2, so which is 20 upon 2 into what is the P2 is this time 2, so 2 2s are 4, so 20 upon 4 comes out to be 4, 5s are 20. Okay, what about person B? So X B1, that means gross demand of good 1 by person B is equal to MB we got here 30 divided by P1 upon P2. P1 we assumed 1, P2 we got 2, so 1 plus 2 is 3, which comes out to be 10. And symmetrically XB2 will be also equal to 30 upon 3, okay, which comes out to be 10. Okay, these are the gross outputs of each good. Okay, now what is the net output? Okay, or net demand, what we call excess demand. So net output will be equal to gross output XA1 minus WA1. Simple thing. This shows the gross demand net demand is equal to gross demand minus the initial endowment of good 1 that person A is holding. So gross demand is 10. Okay, and how many units person A is holding of good 1 0. So which comes out to be what we call excess demand or net demand, or excess demand is 10 for good 1. Similarly we can calculate it for good 2. So how do I show it in notation terms? So let me write it here: n net demand by person 1, okay, is equal to this, or excess demand. Okay, so let me write it here, it will be more convenient. Excess demand of good 1 by person A is equal to 10, and similarly excess demand of good 1 of good 2 by person A will be equal to x to A units of good 2 person A is having minus this is the gross demand of good 2 by person A minus the initial endowments of good 2 person A is having initially. So gross we got 5, and how many units he has initially? 10. So we have 5 minus 10, which means 5. Obviously it is minus 5, minus 5. That means person A will sell 5 units and buy, person A will demand, rather he will buy 10 units of good 1 and sell 5 units of good 2. And symmetrically, if you can find out here, for person B, it will be the opposite. Okay, so for person B, what is the excess demand? So excess demand by person A of good 1 will be equal to xb1 gross demand of good 1 minus initial endowment of good 1. And what is gross is 10, and what is initially he holding 20, so which comes out to be minus 20. So it is minus 10, minus 10. That means he will be supplying 10 units of good 1, and obviously you can see here he is selling 10, he is receiving 10, and excess demand of good 2 by person B will be equal to gross demand of good 2 by person B minus initial endowment of good 2 by person B. So gross is 10, initially how many units he is holding? 5. That means 10 minus 5 is 5. Okay, so these denote our gross demand of good 1 and 2, and these denote us our net demands of good 1 and good 2. How do we show it on the Edgeworth box? Okay, so let me, okay, you can also check it here. We saw here demand for good 1 was equal to supply of good 1. That means first market was in equilibrium, and by Walras law we know if we have n markets and if n minus 1 markets are in equilibrium, that means nth market will be also in equilibrium. We got the equilibrium condition for good 1 market. We don't need to calculate the equilibrium condition for good 2 market, because Walras law tells us that if we have n markets, if we have n markets, if n minus 1 markets are in equilibrium, that means nth market will be also in equilibrium. In this case we were having only 2 markets. If we have 2 markets in the economy, and if 2 minus 1 markets are in equilibrium, that means first market is in equilibrium, then n which is 2, that means second market will automatically be in equilibrium. Okay, so how do we show it on the Edgeworth box? Okay, so let me try to show this on Edgeworth box also. So we will have an rectangular Edgeworth box kind of thing. So this is agent A, agent B. Now total supply of good A is good 1. Let us show it. Good 1 here, good 2 on this axis. How many units of good 1 we have? so WA1 plus WB1, so we have 20, so the width will be 20. And what will be the height? So good 2 is here, so WA2 is 10 plus 5 is 15. Okay, so 15 will be the height of this Edgeworth box. Also, what we have here, since on this axis we show the utility function of person A, on this axis we show the utility function of person B. Okay, so for person B we have min function. Okay, that means xb1 should be equal to xb2, so it will become 45 degree. Okay, so it will come out to be 45 degree. The indifference curve of person B will lie like this. Okay, because this is the perfect complement utility function. Since how do we solve the perfect complement utility function? Whatever is in the brackets, we equate them and solve them. So this is the 45 degree angle here. What about person A? Person A is Cobb Douglas kind of person. So for person A, so for the sake of simplicity, what we got here, let me show it here. XA1 was 10, so 10 units person 1 is demanding, and he is demanding 5 units of good 2. Okay, let me write it here, 0 5. And corresponding to this, what is the units of good 2 person B demanding, which is equal to 10. Okay, because this is 5, this is 10, height is 15. And corresponding to this, units of good 1 person B is demanding, which is 10 also. Okay, so I don't want to make it messy here. What was the price ratio? 1 is to 2. Okay, P1 upon P2 is equal to 1 upon 2. So we have, if it is 20, let us say this is 10 here, our budget line will pass. So this will be our budget line, and this, if this is the utility function, the utility function of person A will look like this, and it will pass through this point. Okay, and here this is the utility function, and this point will denote our equilibrium allocation point. Simple thing. Person A was having initially 0 units of good 1, as we can see. Now he is demanding 10 units. Okay, so demand of good 1 by person E is 10. Initially he has, person B has 10 units of good 2. Now he is only demanding 5 units of good 2, so he will be selling 5 units of good 2. Similarly, person B has initially 20 units of good 1. Okay, so initially we will be at this point. Okay, now we have moved from this point to this efficient point. After that, we can see he is only consuming 10 units of good 2. That means he is supplying 10 units of good 2, and initially he was having only 5 units of good 1. Okay, but he is now consuming 10 units of good 1. That means he is demanding 5 units of good 1. Okay, so this is how do we solve this kind of question. I'm sure that you did not get any idea of this, but I have made these how to draw the Edgeworth box, how to find the Pareto efficient point. And by the way, this will be the Pareto efficient point. Okay, so we cannot make anyone better off without making any other else worse off at this point. Okay, uh, learn how to derive demand functions for Cobb Douglas and Leontief utility functions. Okay, so let us say we are being given this Cobb Douglas utility function, where utility is equal to x1 into x2. X1 and x2 are the two goods. Okay, so this is our Cobb Douglas utility function. Let us write the budget constraint something like this: price of good 1 times units of good 1 plus price of good 2 times units of good 2 should be equal to the total income. Okay, so we want to maximize this utility subject to this budget constraint, and then we will derive the demand functions. Okay, so first step is, we set marginal rate of substitution equal to the price ratio. Okay, marginal rate of substitution, we set it equal to price ratio, and also we construct the graph here. Okay, so let me show it graphically also to make a sense here. So let us say this is our budget constraint. X1 good is here, X2 good is on this axis. Okay, so marginal rate of substitution should be equal to the ratio of the price. Okay, so what is the coordinate of this point? If this is the budget line, what is the coordinate of this point? At this point, when we put x2 is equal to 0, okay, so this whole stuff becomes 0. That means x1 is equal to m upon p1. So here we will have m upon p1. Okay, all income will be spent on good one. And what is the coordinate here? Simple, put x1 is equal to 0, so x2 will be equal to m upon p2. Okay, so at this point all income, sorry, all income is spent on good x2. Marginal rate of substitution means simply marginal utility of good 1 upon marginal utility of good 2 should be equal to price of good 1 upon price of good 2. Okay, and our indifference curve will look like this. Okay, this is our indifference curve with a given, we want to maximize our utility with the given budget. So when the budget line and indifference curves are tangent to each other, that is when this condition is satisfied, we are at equilibrium position. Marginal utility of 1 means derivative of utility function with respect to good 1. Okay, this comes out to be, take derivative of this utility function with respect to x1. So derivative of x1 is 1, we are left with x2. Similarly, du upon dx2 means taking derivative of this utility function with respect to x2. So taking derivative of x2, so it will become 1, so we are left with x1. Okay, simple stuff. So using this very situation, marginal utility of good 1 is being shown by this thing, and marginal utility of good 2 is shown by this thing. So marginal utility of 1 is equal to this, and we got it as x2, and marginal utility of good x2 is this du upon dx2, which comes out to be x1. It should be equal to the ratio of price p1 upon p2. Solve for x2, so x2 is equal to p1 upon p2 into x1. Okay, now just plug this value of x2 back in our budget constraint. Okay, if I put it in the budget constraint, what will I get? So we have p1 x1 plus p2. The value of x2 is this, what is it? It is p1 upon p2 x1. It should be equal to income. Okay, so here p1, sorry, p2 and p2 will get cancelled. This thing and this thing will get cancelled. We are left with p1 x1 plus p1 x1 is equal to m. That means twice p1 x1 is equal to m, which gives us x1 is equal to m upon 2p1. So this is the demand of good x1. Okay, demand for good x1, and here at a point where indifference curve and budget line intersect, corresponding to this we get the optimal demand is m upon 2p1. Okay, symmetrically we can say, or we can show that here demand for good x2 will be equal to a malak drama, it will be equal to m upon twice p2. Okay, so you can just use this, just plug this again in the budget constraint to get the value. Okay, so let's put it in the budget constraint. So I should you know how to calculate then this. Okay, so if x1 is equal to this, so let me also show it here. So we have p1 x1 plus, sorry, p1, what is the value of x1? We got it as m upon 2 p1 plus p2 x2 is equal to m. Okay, so we have here m, m, sorry, why we don't have m here? So this p1 and p1 will get cancelled. Okay, so we are left with m upon 2 plus p2 x2 is equal to m, which gives us p2 x2 is equal to m. Transposing this here, it will become minus m upon 2. So this is p2 x2 is equal to 2m minus m is only m upon 2. That gives us x2 is equal to, you know, m upon transposing this, it will get divided p2. This is the demand function for x2, which I was telling you that it will be here. Okay, so I also calculated it to make the things, you know, simpler. So this was about the Cobb Douglas utility function. What about the Leontief preferences? How do we solve this kind of question? Let us say we have budget like this: p1 x1 plus p2 x2 is equal to m. Okay, we want to maximize utility subject to this budget constraint. Okay, now the utility maximizing bundle will lie where our, you know, budget line meets this kind of utility function. Okay, to solve this kind of question, what we do, we don't use the marginal rate of substitution, we don't take the derivatives because it is not differentiable at all points, this min function. Okay, what we do when we are encountered with this min case type function, we simply equate whatever is in the bracket. So in brackets we have minimum of x1 x2, so let us equate them. That means x1 is equal to x2. Okay, now put this value in the budget constraint. So x1 is equal to x2, so we have p1 in place of, let me write it here, x1 plus p2 in place of x2, I will write x1 will be equal to m. So we have, taking x1 common, we are left with p1 plus p2 is equal to m, or x1 is equal to m upon 2, sorry, transposing this, p1 plus p2. Okay, this will be the demand for good x1 when we have Leontief preferences. Okay, similarly or symmetrically you can calculate for x2. That will be same, that means x2 will be equal to m upon p1 plus p2. Just substitute this back in demand function, you will get. Rather, since x1 is equal to this, we know x1 is equal to x2, that means x2 will be also this m upon p1 plus p2. Okay, now how does the graph look like in case of perfect complements, what we call Leontief preferences? So this is our budget line. Hey, this is our budget line. Okay, so we have x1 here, x2 here. So this is a coordinate where all income will be spent on x1, so m upon p1. So here this is m upon p2. Okay, and we also got x1 is equal to x2, so our ray will look like this. Okay, 45 degree in this case, and the indifference curve in this case will be something like this. Okay, so at equilibrium, this is our indifference curve. Our indifference curve will meet the budget line at its kink. That means the corner of the indifference curve will touch the budget line in case of, you know, perfect complementary utility function when we try to maximize it. Okay, so demand function in case of perfect complementary utility function was that the demand for good was a function of income and price of good 1 and price of good 2. Okay, so demand for good 1 is function of three variables, that is income, price of good 1 and price of good 2. But in case of Cobb Douglas utility function, demand for a good was a function of only income and its own price. Okay, so you can see the difference here. In case of Cobb Douglas utility function, demand for good was a function of income and price of this good itself, not on the price of other good, what we call x2. So this is the basic difference between the Cobb Douglas utility function and what is the demand function, and about the Leontief utility function, what we call perfectly complementary utility function also. Okay, so in case of Leontief utility function, demand for x1 here depends on income, price of the two goods. But in case of Cobb Douglas, it is only the demand for it depends only on the income and its own price. Okay, so where should I show the demand function for good 2? So this was for good 1, so symmetrically x2 which I calculated was equal to m x2 was m upon 2p2. Okay, so these were the demand functions for Cobb Douglas preferences. These two are the demand functions for Leontief or min functions. Okay, thank you.